Hi, everyone. In this session, we'll look at the test 3 review problems. The first problem asks, given the following functions, find and simplify f plus g of 2, given that f of x equals 3x squared plus 1, g of x is 3x minus 1. For this one, because it tells us to add the two functions, we're going to do that first. And then in the resulting function, we'll substitute 2. So let's add f plus g. We'll add f of x is 3x squared plus 1. We're going to add 3x minus 1. We'll add like terms. It's 3x squared plus 3x. The 1 and the minus 1, they're going to cancel each other out. Okay, so in here, we're going to plug in 2. So 3 parentheses 2 squared plus 3 parentheses 2. And we get 3 times 4 plus 3 times 2 is 6, which gives us 12 plus 6, resulting in 18. Okay, let's take a look at number 2. Here, given the following functions, compute the composition f of g of x. For this one, it's asking us to input g of x inside x. So we write this as f of g of x is equal to 5. And for x, we're replacing with g of x, it's 6x minus 8 plus 2. And then let's distribute the 5. We get 5 times 6 is 30x, minus 5 times 8 is 40, plus the 2. And then add like terms, negative 40 plus 2, we get 30x minus 38. Okay, number 3, determine the vertex of the graph of the following parabola. This is a quadratic function. And if we were to graph this, it would look like a parabola that opens up. It opens up because x squared, the leading coefficient, the number in front of that is positive. So we're looking for the vertex, which in this case is the minimum point. The formula that goes with the vertex when it's in this form, ax squared plus bx plus c, we find so here's the h is just the x value of the vertex, and 8k is the y value of the vertex. To find x, we're going to use a formula negative b over 2a, where b is the negative 24. So we have negative of negative 24 over 2 times a. A is the coefficient in front of x squared. In this case is 1. Negative negative is a positive 24. 2 times 1 is 2. And then we get 12. So that's our x value. And to find the y value, we just plug it into the function that's given. And so we plug in 12 squared minus 24 times 12 plus 20, and that'll give us 144 minus 288 plus 20, which gives us negative 124. And so the vertex is 12 comma negative 124. Okay, question 4, find the y-intercept of the function 6x squared minus 15x minus 11. Whenever you want to find the y-intercept, you always substitute 0 for x to solve for y. So we'll plug in 0 into the function, 6 parentheses 0 squared minus 15 times 0 minus 11. 0 times anything is 0, and that'll be 0 as well. So we get negative 11, and it wants it the answer as an ordered pair. And we have 0 comma negative 11 as the y-intercept. Number 5 wants us to find the real zeros of this polynomial function. F of x equals x to the 6th plus x to the 4th minus 30x squared. First, I'm seeing that they all have a common factor of x squared. So let's, well, actually, we first set the whole equation equal to 0. And then we're going to factor out an x squared, which leaves us with x to the fourth plus x squared minus 30. And then we're going to try to factor this term here. We have x to the fourth plus x squared minus 30. That I'm going to use my cross method. What multiplies to negative 30 and adds to the b term, which is 1, and that's going to be 6 and negative 5. So this term factors as x squared plus 6 minus 5. After everything's factored, we set each factor equal to 0. So we have x squared. So we have x is equal to 0. There's our first 0 or x-intercept. We set x squared plus 6 equal to 0. And to solve for this, we have subtract 6 on both sides. We get x squared equals to negative 6. If we take the square root of that, we get x is equal to plus or minus. Square root of a negative 6 is going to give us I squared of 6 because it's not a real 0. It's an imaginary 0. We're not going to count that. So we have x squared minus 5. We set that equal to 0. Add 5 to both sides. Get x squared equals to 5. Take the square root. We get x is equal to plus or minus square root of 5. Okay, so we have 3 solutions. We have 0, negative square root of 5, and positive square root of 5. Okay, number 6, find and simplify f minus g of 1. We're going to, we could subtract this and say f of x, which is negative x squared minus x minus 3. And when we subtract, we have to make sure we put the parentheses around the g of x function. So we're subtracting the negative 1, which will simplify to negative x squared minus x minus 3 plus 1, which will then be negative x squared minus x. Negative 3 plus 1 gives us negative 2. So now we could substitute 1 into this function. We get negative 1 squared minus 1 minus 2, which gives us negative 1 minus 2. Simplifies to negative 2 minus 2, and that simplifies to negative 4. Okay, number 7, given the table below, determine whether y is a function of x and the function is 1-to-1. Basically here, you're trying to see if there's repeated x values being mapped to more than one y value. So you see 6 is paired with negative 1 and negative 5, and you can't have two, for it to be a function, each x value can only have one y value because 6, it has 2 y values, negative 1, it's assigned to negative 1 and negative 5. We say y is not a function of x. Okay, number 8, which of the graph show a function that's 1-to-1? A 1-to-1 function has to pass the horizontal line test. And so if you draw a horizontal line and it goes through it more than once, it fails. So this is not a function or not a 1-to-1 function. This one is okay because it only passes it once. This function is okay too, but this one, it passes it, goes through, the horizontal line goes through it twice, so this is not. And so the only two 1-to-1 functions is this one and this one. Okay, number 9, the graph of g of x is equal to negative 4, f of x minus 3 minus 3 is the graph of f of x. We want to look at what the transformations are. So there's different, oops, things going on. If you have, let me just rewrite this again. Okay, if you have a negative in front of the function, this is telling me that there is a reflection across the x-axis. This 4 here is telling me that it's a vertical stretch by 4. And this -3 inside the parentheses tells me that it's a horizontal shift. And it's -3, but horizontal shifts go the opposite direction. So this is to the right 3 units. And then the -3 at the end tells me that it's going to go vertically down 3 units. It's doing lots of things here. So I need to choose the one that does that vertically stretched by a factor of 4, reflected across the x-axis, and shifted right 3 units and down units. So it looks like it's this one. Okay, number 10, here's another similar one. Let me just recopy that down here again. Your g of x equals -1/4 f x of x minus 6 minus 2. Okay, so the negative again here tells me it's it's reflected on the x-axis. The 1/4 tells me that it's a vertical compression because it's 1/4. By a factor of 4. The x minus 6, again, this tells me that it's to the right 6. And the -2 tells me it's going to down 2 units. So let's see which one this is. Vertically compressed by a factor of 4, reflected across the x-axis, shifted right 6 units and down 2 units. It looks like it's this option. Okay, number 11, similar idea, but this time it wants us to graph. Because I can't physically play around with this graphing tool because this is a copied image. But how I would approach this is I would take each of these points and then follow what the transformations are. And so f of x plus 1 tells me that it's going to go right, or actually go the opposite way. Left 1 unit. And then the +2 tells me that it's going to go up 2 units. And so with these 2 red points on the original graph of f of x equals x squared, I'm going to take each point and go left 1 and go right 2 and go left 1, right 2. And then I could also even just take this one, left 1, right 2. And so these points, you would have to physically move them so they look like this. The whole red graph should end up being the blue graph. So if you had moved this correctly, right, it would look like a graph that I have on here that I drew. And just take each point, move it left 1 and up 2 units. And so the points would be at, so this would be at 0, 3, and this would be at -1, 2. Okay, number 12, we want to find the inverse function of f of x equals 5x squared minus 5, where x is greater than or equal to 0. Okay, so there are a couple steps to do this. First is to replace and rewrite this as y equals 5x squared minus 5. This is just easier to work with y than f of x. And then we're going to switch the x and the y's and write x equals 5y squared minus 5. And then we're going to try to solve for y. And we can do that by adding 5 here to both sides. And we get x plus 5 equals 5y squared. And then you take the 5 away by dividing both sides by 5. And we get x plus 5 over 5 equals y squared. And then we'd get rid of this y squared by taking the square root of both sides. And that gets rid of the squared. And so we get y is equal to the square root of x plus 5 over 5. And that's going to be your inverse function that you type in here. F inverse function of x is the square root of x plus 5 over 5. Okay, 13, another one to find the inverse function, f of x equals square root of 3 square root of x minus 2 plus 11, where x is greater than or equal to 2. Similar idea, we write it as y equals 3 square root of x minus 2 plus 11. And then you switch the x and the y. X equals 3 square root of y minus 2 plus 11. And let's solve for y by subtracting 11. So our goal is to solve for y now. And we get x minus 11 equals 3 square root of y minus 2. We need to get rid of this 3 first by dividing it away on both sides. I'm going to carry it here since I'm running out of space. So we have x minus 11 over 3 equals square root of y minus 2. Okay, we take the square root off first by raising both sides to a power 2. So we get x minus 11 over 3 squared y minus 2 because the square root got canceled out. And finally, we're going to add 2 to cancel this 2. Add 2, and we get x minus 11 over 3 squared plus 2 is equal to y. So that's your inverse function. I'll just write it here. So your inverse function of f is x minus 11 over 3 squared plus 2. Okay, 14, determine the x-intercepts of the parabola whose graph is given below. So the x-intercepts, it's where the graph crosses the x-axis. This is the x-axis, and it's crossing at this point, which is -3, 0, and 1, 0. When you type it in, just type it in as -3, 0, comma, 1, comma, 0. 15, determine the vertex of the graph of the following parabola, negative x minus 9 squared minus 7. And so to determine that, you when it's in this form, you take the opposite of the minus 9. So it's going to be, the x value is going to be positive 9. And then the y value you take as is, minus 7. And because this is in the form f of x equals ax minus h squared plus k. Your h is the x value of the vertex, and k is the y value of the vertex. So when it's this form, it's really easy. You just take the opposite sign of the x, and then the y value you just take as is. So the vertex is 9, comma, -7. 16, use the rational zero theorem to find the zero of the function. This problem is a little tedious. So with cubic functions, we know that it's going to either have 1 real 0 or 3 real 0. And to use the rational zero theorem, you take the p-value, which is this is the p, the last constant term, And then you have to find all the factors of 45, which factors are going to be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, and finally plus or minus 45. And then you take the Q, which is the first value 3, and you find all the factors of 3. And then you have plus or minus 1, plus or minus 3. Then what you have to do is divide each of the P's by the Q. So you take 1, divide by 1. So if you take P over Q, you get plus or minus 1. 3 over 1 is plus or minus 3. 5 over 1 is plus or minus 5. And plus or minus 9. 15 over 1 is plus or minus 15. Plus or minus 45. Then you also have to divide everything by 3. Plus or minus 1 over 3. Plus or minus 3 over 3, but that's 1, so I won't write that down. Then 5 over 3. 9 over 3 is 3, so that's already written, so I won't write that. And then we have 15 over 3, which is 5. And 45 over 3 is 15, so I won't write that either. So these are all possible, right? They're not the actual zeros. These are all possible zeros of the function. And in order to see which one is the function, you have to put in each of those into the function and find the one that gives you 0. Okay, I already worked it out and then figured out that -9 works. If you plug in -9 into the function, get 31 -9 squared plus 41 -9 plus 45. And plugging that into the calculator gave me 0. So that tells me that -9 is a 0, the function. But to get to that point, right, I would have to plug in 1 and see if that gave me 0, and it didn't. The 3, I tried the 3's and that didn't, plus or minus 5 didn't, and the 9, positive 9 didn't work, but -9 worked. And so -9 is the 0 of this function f of x. You could also, a good way to also approach this is you could also graph this using your graphing calculator and seeing where it crosses the x-intercept. Okay, 17, f of x is given x to the third plus 5x squared plus 43x plus 111. And it's given us that -3 is a 0. So for this, I would use synthetic division and write -3 as my corner number and bring down all the coefficients of your function. So we have 1, and then the 5, and then the 43, and then 111. And then the synthetic division is you bring down the first number 1 and you multiply that 1 by -3. And 1 times -3 is -3. We add these 5 minus 3 is 2. You multiply 2 times -3 again, and we get -6. 43 minus 6 is 37. 37 times -3 is -111. And you get a 0. And that shouldn't be a surprise because we already know -3 is a 0, and this is the remainder. You're always going to get a remainder of 0. So now we take these values and we're rewrite that as 1 exponent less than the original, x squared plus 2x plus 37 equals 0. Now, either I would have to try factoring or use quadratic formula or completing the square. I'm going to use the quadratic formula to solve for the other zeros. And remember, quadratic formula is, I'll write it here, -b plus or minus the square root of b squared minus 4ac all over 2a. And we know in this case, a is equal to 1, b is equal to 2, c is equal to 37. So we have x is equal to -2 plus or minus 2 squared minus 4 times 1 times 37 all over 2 times 1. Okay, I think I need a calculator for this. So if I put 2 squared, I'm going to do it right now, minus 4 times 1 times 37, I get negative 144 under the root. 2 times 1 is 2. And then we have negative 2 plus or minus square root of negative 144 is 12i. Because it's a negative under root, square root of 144. If I do that on the side, can be written as square root of 144 times the square root of negative 1. Square root of 144 is 12, and square root of negative 1 is I. We divide by 2, and if you take each of these and divide by 2, negative 2 over 2 is negative 1, plus or minus 12 divided by 2 is 6i. Okay, so the other solutions, it says list of 0 separated by a comma. You could list it as negative 1 plus 6i, comma negative 1, oops, negative 1 plus 6i without the comma there, and negative 1 minus 6i. Okay, this next one, let's see, it's actually very similar to the one we just did. It's given below negative 3 is a 0, find the other 0 of f of x. So this would be good to stop and see if you can do this on your own before watching me go through it. Okay, so negative 3, we're going to use, and then we have 1, 7, 52, and 120. And we bring down the 1, multiply by negative 3, 7 minus 3 is 4. Multiply 4 by negative 3, get negative 12. 52 minus 12 is 40. Multiply by negative 3 is negative 120, and again, there's 0. Rewrite this as a quadratic equation, x squared plus 4x plus 40 equals 0. I'm going to use the quadratic formula again. X equals negative b. So here a equals 1, b equals 4, c equals 40. So x equals negative 4 plus or minus b squared, 4 squared minus 4 times a times c over 2 times a. Okay, let's simplify this. Negative 4 plus or minus. I'm going to put this in my calculator again and calculate what is 16 minus 4 times 40. Gives me negative 144 again. Over 2. So again, that's negative 4 plus or minus 12i over 2. Take each one, divide by 2. Negative 2 plus or minus 6i. So the solution, because again, we need to sort of separate it with the comma. Negative 2 plus 6i minus 2 minus 6i. Okay, number 19, we need to find and simplify f of g of 4, or f times g, excuse me, 4.5. So it means this time we're going to multiply fx, f of x, and g of x. Or we could just do these separately as well. I could multiply f of x to g of x, or I can just do find f of 4.5 and find that what that is, g of 4.5, find that what that is, and then multiply the two results together. So if we have negative 4.5 plus 2, that's going to give us negative 2.5. We plug in 4.5 in for g, 6 times 4.5 minus 1, which gives us negative 27 minus 1, which is negative 28. So with these two, I'm going to multiply these together. Negative 2.5, because we're multiplying f times g, with negative 28, we get positive 70. Okay, last problem, number 20. Find the vertex of the parabola where of the graph below. And so the vertex of the parabola is right here. This is a parabola that's opening up. So the vertex is this point, the minimum point, and that's negative 1 for x and 3 for y. So it's negative 1, 3. Okay, I hope you found this session helpful. Again, you can rewatch this and try to do the problems on your own again, but you have 2 attempts on this test. So you can treat the first attempt as, I mean, you want to do your best on it, but treat it as like the practice test and then take advantage of the second attempt. Because I do take the highest score. So good luck. Again, if you have any questions, feel free to reach out.